Hi everyone, thanks for taking some time in your morning to attend this talk. So I'm going to talk about, maybe that way. I'm going to talk about the challenges and secrets of the real-time world, like real-time applications, real-time infrastructure, all the things that allow you to create real-time apps. So I am Martin Lagrange. I am a software engineer. Work at PubNub, a real-time data stream network. You can find me. I'm Super Tinu on Twitter. I'm Super Tinu on GitHub. The aim of this presentation is to be as simple as possible. I didn't want to go much into the details, but we will tackle the main things. So first of all, I would like to show you a short video that gives you a bit of context about what are the real-time apps. So these are just examples of real-time apps, Periscope, just ride-sharing applications, games, IoT and remote control. All this stuff are real-time applications. And when you talk about real-time apps, it means real-time data. So if it's a ride-sharing app, messaging app, trading apps, will be different kind of data. And in order to share this data and have this data coming back and forth between the device or clients, you need a protocol. And for that, you need a real-time protocol. And what is the real-time protocol, actually? A real-time protocol is a protocol that allows you to have always-on connection, which is bidirectional, fast, and which is supported everywhere. And that's all we need to do real-time applications. So people would think, okay, well, I will do some HTTP polling to add some real-time feature in my app. Yeah, I will poll my server every 1 second. It's gonna be alright. But yeah, it's not gonna be real-time. It's not gonna be efficient. It's not gonna be always on, not scalable, and so on. So there are a lot of protocols out there: HTTP streaming, WebSocket, Kafka, MQTT, long polling, server-side event, socket.io, WebSocket, all this stuff. And what make them different, and what's the best protocol? It's kind of a hard question. It's kind of a tough question to answer. Actually, all the different main real-time apps like Facebook Messenger, Facebook itself, Slack, Uber, WhatsApp, all this. When you think about this main companies that are using real-time features intensively, they are all using different protocol: XMPP, Kafka, HTTP long polling, WebSocket, and so on. And what makes them different? So actually, they all work on top of TCP. And so you maybe remember these OC layers. You have the TCP on the network layer and the application layer with all the protocols, which are all working on top of TCP. And so they are all sending TCP packets at the end of the day via TCP sockets. Blah, 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 TCP packets. So when you initiate a real-time communication with a server, what are the steps that are needed to be done? So first of all, you need to do a DNS lookup to get the address of the server. So you do the DNS lookup via the UDP protocol, and you get an IP of a server, and then the server, you will reach the server and initiate a TCP socket. For a TCP socket connection, you will need to do a TCP handshake, TLS handshake, and finally the request. So exchange round trip of TCP packets. So what makes a TCP connection real time what makes it different than other protocols like HTTP or basic raw HTTP or POP3 or any other protocols is that both the clients and both the servers will understand each other that they need to keep this TCP socket open. And that's for all the different protocols, that's the same thing, is that the client and the server keeps the TCP socket open. So that once the TCP socket is open, then they exchange TCP packets, and most of the time the server will just push some some data to the clients. So I like to talk about HTTP long polling. So Facebook uses it, so it works well, but it's kind of tricky because what happens with TCP sockets, if you look at, if you inspect your network calls from the Google developer tools, is that you open the XHR tabs. By the way, if you just like the tips you want to inspect, you can also use the WebSocket tabs, and you can see what our technologies are used, what technologies are used for real-time features. So for Facebook, you will see a lot of different requests that are made against the server, and HTTP link polling, how it works is that it opens a connection and then it keeps it open, and then when the data is available from the server, it will stop the connection and give you all the data available, and then the client needs to reconnect again and again to fetch the data. So it could be considered as a hack, but it works well. So what is tricky is that you would think maybe, so there is always like connection made against the server. So you would think, okay, so the TCP socket needs to be initiated all the time. I need to do DNS lookup. It's going to introduce a lot of latency, and you're going to need to do TCP handshake, TLS handshake, and all this stuff. But actually, since HTTP introduced the keep alive feature, your TCP socket is going to be reused for the next connections. And you will think that you have different requests and different TCP sockets, but it will be the same TCP socket. So there is one thing with HTTP long polling is that it uses HTTP, so it introduces a bit of overhead because the headers are really heavy compared to other protocols, which are more lightweight. And one thing is, if the connection drops, you will need to reconnect again. For all protocols, it's the same. You need to do the same thing again and reinitiate the TCP socket. So I wanted to show you under the microscope what makes the protocols different, and we saw that it's not that different. It mainly depends on the packets exchange when the TCP socket is initiated. So people will think, okay, yeah, use WebSocket, use XMPP, but just the protocols is not sufficient enough. You need a server, an infrastructure behind the scenes to make all these things happen. So how it works in the hood is all the clients is going to connect against the server, going to open connection, and the server is going to work as a hub, and distribute all the different messages to the different clients which are subscribing to kinds of channels or topic. So how it works, most of the time you have like this concept of channel or topics, and you can subscribe to different channels, and the server is going to register your client so that when your client is subscribing to one channel, if there's other clients publishing, they're gonna push this data to the open connections. And scaling is a really huge challenge for the real-time servers. So you need to select which host you're gonna send the connections to. You need to make sure that all the clients publishes the data to one host will have the data available to the clients subscribing to a different host. and amongst different servers, and you need to scale horizontally among different CPUs and vertically and horizontally, and it's a big challenge. One other challenge is this feature called multiplexing, because you want to avoid different TCP connection against a server when you want to fetch data from different channels. And in order to do that, you need to have like a sort of a feature that allows you to receive this data via. You need to allow you to subscribe to different channels, and push data gives you a queue that is unique to your subscription. So just here is an example of one client subscribing to 2 channels, and the server will forward the messages. There is another challenge is when you lost internet connectivity. So you may think, it's not an issue, but it's more common than you would think that to lose internet connectivity. And your app can be really sensitive to internet connectivity issues, and so when your connection is lost, then you will miss the messages that are published between the time that you were not online. And in order to prevent that, you can have a kind of a catch-up feature that is not out of the box for all the apps, all the frameworks, that will allow you to kind of resubscribe when your connection drops with a timestamp or a sequence ID to allow you to resubscribe and get all the missed messages that you lost. Another challenge that you wouldn't think is, what about if my users are everywhere in the world? You maybe don't see what is the challenge here, is that if you have a client in Japan, if you have a client in Brazil, and if you have a client in the UK, let's say the client in the UK publish a message and subscribe a message to a data center in Ireland. You need to like the users in Japan and Brazil. It's going to be it's going to introduce a lot of latency to connect directly to the server in Ireland. So you maybe familiar or not with the concept of CDN, Content Delivery Network. So that what allows you CDN is to have the data cached in different servers in the world, so that depending on the location of the user, it will connect to the closest data center to him. And what is the challenge here is that it's different with real-time data, is that the data is always renewed, and you cannot cache this data. It's always new data. So what you can do instead, which is more faster, is to have, when a user publishes a message and subscribe to a message, you can have this data replicated to different servers in the world to allow you to have all the users subscribing to their own servers, which is closest to their location. And you would think, you would be surprised, but it's faster to replicate this data amongst the different data center servers and have this user connect to the closest data center. So how it works? It works with the concept of GeoDNS that will allows you to with the concept of DNS subnet information that the client will provide when he did the DNS lookup request. The DNS server will be able to get the location, the public IP of the customer, and knows where he should, which IP, which server he should give back to the DNS lookup request, so that the client connect to the closest. So as a summary, I will say real-time is awesome. the protocols are not that different, and the protocol is not the only things that matters. Scalability is a big challenge with, regarding real-time framework and servers. Multiplexing is something that you may need to have, which is not out of the box, and also have a policy for recovery issues and a geo redundancy, so you have a full, like you have your app which is really fast for different user in the world and anywhere. Thank you very much for your attention. To thank you, I have some gifts for you. I printed out it's called a zine from Julia Evans, which is really cool about networking hacks. So I have it with me. I have like kind of 50 copies. So if anybody wants some, just feel free to get it. It's really, really neat. Yeah, if you have any question, let me know.
One, two questions eventually.
Yeah. Yeah, please.
So the replicating the data across different locations, like from Japan to Spain, is there anything that helps you do this, or do you have to build it all yourself? Are there any open source libraries to help you with that?
Yeah, so the question is, if the replication thing that I mentioned earlier, to replicate between different servers, is there something that helps you out for this, and is there an open source library or not? And the question is, as far as I see, so you can build yourself, but I'm not aware of open source things or that will, or even like the document on the internet that will help you with that. Okay. Easy answer. Yeah, please.
Will the wonders of HTTP version 2 help you in this?
Yeah, it's a good question. So the question is, what about HTTP 2 will helps you with this? So you can maybe think about HTTP 2 and long polling. So HTTP 2 introduced a feature called server push. You would think it will help you on that, but actually it's not a server push regarding data like WebSocket, like data coming to your browser. It's more about assets, so you can't get this data. It's not something, I just want to mention that it's not, this feature called server push is not something that will suit with that. What HTTP2 introduced as well is to use, so you can have different, you can use one connection and have different different requests in the same connection. So yeah, I don't know what to answer. I was thinking in the same time, but yeah, I don't think it would. Let's maybe more. Let's read about that.
Okay.
Yeah.
Yeah. In the very beginning, you showed the pictures of games, video games, which is catchy, of course. But do you think your platform is able to handle efficiently multiplayer games? Is it efficient enough, fast enough? What
do you mean by your platform?
The latency, do you think it's low enough to be able to do massive MMORPG or something like that?
I would say it depends. So there are protocols that are more suitable for that. So WebSockets are definitely something that, or I mean, other protocols that have less overhead in the packets that are exchanged between the server and the clients are more suitable for that, because you want less information sent, but definitely will help you. It will be suitable for that. Yeah.
Okay. Okay.
That's all the time we got.
Thank you.
Thank you. And feel free to grab a